Welcome to this video. Take a moment to pull out your notes on momentum and we will take some notes, do some practice, and proceed in that fashion. Here's the equation for momentum. Let's make a chart defining the momentum vector, m, and v. In the equation, p stands for the object's momentum, m stands for the mass, and v stands for the object's velocity. We're using velocity, not speed. What's the difference? Remember that velocity has direction, speed doesn't. We measure velocity with meters per second. What's the unit for mass? Kilograms. So what will be the unit for momentum? Take a look up at the equation. If we plug in kilograms for mass and meters per second for velocity, then we're going to be combining those to get a momentum whose units are kilograms meters per second. That's the unit for momentum. It doesn't equal a Newton, doesn't equal a joule, but we'll see its relationship to those in just a bit. Velocity is a vector. We'll deal only with one-dimensional velocity, so we'll represent the direction as positive or negative. Positive will mean like to the right, negative will mean, to the left. Mass can't be negative, it's only positive. And so the momentum will be positive or negative based on the equation. If momentum is positive, that means the velocity must have been positive. If the momentum comes out negative, that means the velocity must have come out negative. So does momentum have a direction? Well, yeah, we know it does. It's a vector, so it has direction. We know that because of the arrow here, and also because the equation uses velocity, and velocity has direction. So we've already answered number 5. Take a moment to answer that question. Mathematically, how do we show to the left? How do we show to the right? So go ahead and write the answer on your page. So we use a positive or a negative. You don't need to write this down. There is two-dimensional momentum. We're not going to deal with that. We won't encounter it. But it would use an angle, theta, for the direction. It wouldn't use positive or negative if it's a two-dimensional momentum. Momentum always inherits the same direction as the velocity. And that's what we talked about earlier up here. So basically what this means is that if the velocity is negative, then so will be the momentum. Take a moment, solve numbers 6, 7, 8, and 9, and pause the video now, and then come back to the video to see those solutions. So pause the video, work with your partner, solve 6, 7, 8, and 9, and then come back to the video to see the solutions. Okay, I assume you've solved it, so here are the solutions to 6 and 7. Positive here because it's east. And negative here and here because it's west. And here's the solution to 8. The first thing we have to do is convert the mass. Oh, not the mass. We have to convert the momentum from kilograms kilometers per second to kilograms meters per second. There's an extra kilo there. We have to get rid of it. Now here's one way to do that. You think about kilograms, you think about kilograms, kilo, meters per second. All of those are separate from each other. But then you just substitute in for kilo. A kilo equals 10 to the 3. And now when you get rid of that extra kilo, the remaining units are what you want, kilograms, meters per second. Then you use the equation, plug in the values, and this is the calculation you'd get for mass. To solve number 9, you multiply mass times v for each of these answer choices. And then you just look and see which one has the biggest calculated value for p, momentum. I believe it comes out to choice B. Now take a moment to solve 10, 11, and 12. Pause the video, do this with your partner, and then come back to see the solution. Okay, I assume you've paused the video, you've solved these problems, given them a shot, and so here's the solution to 10. We're thinking about the equation P equals mv. Inertia is mass. So how could the momentum be small when the mass is big? How can this be small when this is big? Well, it depends on what v is doing. So the answer has to deal with what happens to v. So now, having seen this, chat with your neighbor or find someone else in the room who thinks they've got an understanding of this answer and discuss to see if you all can work out a good way to put this into words together. Number 11, here's the solution. You first, don't forget to label the axes. That's the first thing that you do. We've got momentum is on the y-axis because it comes first. Velocity is on the x-axis because it comes second. You've got the equation for momentum here. You're looking for proportionality between P and V. So there it is. And it's a straight line through the origin. That's the shape of a direct proportionality. For 12, we're doing velocity on the y because it comes first, mass on the x because it comes second. You use the same equation, but now write the proportionality between v and m. P is a constant, so it becomes a 1. Isolate v since it's the first thing listed. And then get v by itself on the left side, so just flip both sides. This is y, m is x, and you see we have an inverse proportionality. We're going to now take some notes on change in momentum. If an object's velocity changes, then so will the momentum. This is the formula for change in momentum. Final momentum minus initial momentum. If we plug in mv for p final and p initial, then this is what the equation becomes. The mass doesn't change from the initial moment to the final moment, only the velocity changes. We can we can factor out an m, and when we do, the equation becomes this. This is the equation that you want to box. This is an equation we will use in our problem solving. So using this equation, go ahead and solve 12 and 13. So once you use the equation for 12, you get the value of positive 60 kilograms meters per second. For 13, you have to refer back to number 12, use the momentum that you got, the change in momentum from 12. So it's assuming the same momentum delta P from 12, that's 60. You plug in 60 right here. The mass is given, it's 0.25, and the final velocity is negative because it's west. So you have to plug in a negative, which means you've got VF plus 4. Now I would divide both sides by 0.25 first, and then I would get rid of the plus 4 by subtracting it from both sides to get the final answer of 236. In number 14, the first thing we need to do is fix a couple values. Change the 0.2 to 0.25, change 15 to 20. Now, don't work on this problem just yet. What we're going to do is wait for everyone in the class to get caught up to this point. Once we have all reached this problem, we've done the rest, everyone's on the same page, here's what's going to happen. We're going to pause the video. Each person will try to solve it individually without helping or talking to anyone. No talk allowed, no help allowed. You can look at your notes. But then, once you've got an initial answer, we are going to stand up, find someone in the classroom with a different answer from us, and try to convince that person that you're right. So we're only going to work on this for about 3 minutes, and then once the 3 minutes has passed, once we've done that individual work for 3 minutes, we'll stand up, find someone with a different answer, convince them that you're right, and then we are going to take a poll as a class. So we'll all raise our hand if we think the answer is A. If we think the answer is B, we'll raise our hand next. If we think the answer is C, and so forth. Okay. So pause the video, go ahead and do this, and then people can go up to the board and explain their answer, but then you can finally watch the video to see what's correct. Okay, so I assume we've all taken a stab at it individually. We've had a chance to chat. We've polled again, and here's the answer. Well, first let me show you a picture. The ball strikes moving to the right, and when it bounces back, that means it's going in the opposite direction, to the left. So the initial speed is 20, but the initial velocity is positive 20. The positive means it's going to the right. The speed is the same at the end, it's still 20, but now it's moving to the left. So the velocity is negative 20. We plug into the equation, negative 20 minus positive 20, to get a final answer of 10 kilogram meter per second to the left. So the answer is B. Okay, we're going to do the same thing that we did for 14 with number 15. Take 4 or 5 minutes to solve this on your own. Think about it, you can look back at your notes, but you can't talk to anyone else and you can't help anyone else. Once we've had a chance to solve it on our own, write your initial answer down. And then you'll stand up, find someone with a different answer, and convince that person that you are right. After we've had a chance to do this, some good discussion, we'll come back together and we'll poll to see how much agreement there is. Does everyone think it's one answer? Are people still divided? We'll see how effective our argumentation was. So pause the video, do the work on your own, stand up, talk, and then we'll look together. After we've all looked together and talked together, we can have people go to the board and try to convince the entire class that they're right. So go ahead and pause the video now. Okay, I assume you've paused the video, you've talked, you've worked alone, you've talked, convinced someone that you're right, gone together again and polled as a class, and then had some board discussion. So here's the correct answer. Ball A will be on the left, ball B on the right. A goes down and it bounces up. B goes down and it stops. Initially, they both have a negative number as the initial velocity. The negative value here is, it's a negative value because the ball is going down. So the initial velocity is negative. For the ball A, the final velocity is a positive number. For ball B, the final velocity is 0. Now, if you look at a number line, we can imagine here's 0, everything on the left is negative, everything on the right is positive. Which ball has a bigger change in velocity? Well, ball A starts at some negative value somewhere over here, and it ends up at some positive value somewhere over here. We don't know what the numbers are, but we know it starts on the left side, ends on the right side, in the positive territory. Ball B starts in the same negative value, the exact same negative value, and only goes to 0. So ball A, down here, ball A, it has a greater change in velocity and therefore a greater change in momentum. So the answer is ball A. And here's another way to think about it. Ball A comes to rest just like ball B. If that were the end of the story, they'd have the same change in momentum. But ball A, not only does ball A come to rest, but then it speeds up again. So its momentum changes doubly because it slows down just like ball A, and then it speeds up. Now take a moment to solve number 16. Notice that we're given grams, and notice they don't tell you which way the ball is going. So you'll have to assume a particular direction and then use magnitude at the end.